The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. I'd like to thank you for joining us for today's webinar brought to you by TRENDnet. I'm Jacqueline Shawn, Marketing Manager for the Electronic Security Association. Just a couple of housekeeping notes before we get started. All callers will be muted for the duration of the webinar, so please be sure to use your question or your chat log to submit all questions, and these will all be addressed at the very end of the webinar. Additionally, a recording of the webinar will be available in the members-only resource library on esaweb.org. ESA credits are also available for attending today's session, so please refer to your chat log momentarily for instructions on how to request those forms. Today's webinar, Building Flexible IP-Based Security Solutions, will be presented by Justin Ritchie and Evan Davis. Before joining the TRENDnet team, Justin was a computer gaming enthusiast and a part-time system integrator. He spent his days working for an IT consulting company and spent his nights working on his computers. Justin was later hired by TRENDnet as a technical writer. Soon after, he was brought up as a sales engineer by the pre-sales department. As a sales engineer, he spent much of his time working with his customers and business partners, designing cost-effective network solutions for the small office, home office, and small-medium business sectors. Evan is a senior sales engineer manager at TRENDnet and spends much of his time helping to train the TRENDnet partners with the latest and greatest of product offerings and has become an invaluable asset to the TRENDnet team. He specializes in finding creative PoE and wireless solutions to many surveillance challenges. He has experience in networking infrastructure and has proven invaluable for countless networking projects. Now, without further ado, I'll go ahead and turn it over to Justin and Evan.
Thank you for that introduction, Jacqueline. So today we're going to be talking about some of the different networking mediums and how you can really combine these together to build, flexible IP-based security solutions. So let's go over some of our topics for today. So we'll just lead off with some company information and whatnot. So we'll just burn through that real quickly because we have a lot of content to cover. Hopefully we can get through as much as possible. So we also want to talk about just the different networking mediums and then maybe go through some sample solutions, some of our products, and just what the advantages are of TRENDnet. So without further ado, let's get started because we have a lot to get through today. Okay, so just some background of our company. We're privately owned, been in the industry for 22 years. We currently market 300 plus products, and our office and warehouse is in Torrance, California, which is where we are now. We're actually in this room right here, if you can see my mouse cursor. And we have a green environmental position. So when anything you see that says TRENDnet, that actually is uses power-saving technology. Okay, so networking mediums means switches. We want to talk about what a switch has been around for quite some time. Switches are very similar to hubs, but they're actually much more advanced, even though they look and function a little kind of similarly. So the biggest difference with a hub is a hub would actually just broadcast information to each and every single port, so it actually was very inefficient. But very simple. So switches, even though we call these unmanaged or dumb switches, they're actually very smart devices. So they actually, in a way, route traffic, to the necessary ports and everything. So you're not getting that broadcast through all ports. So that's what really makes a switch different from a hub. The other thing that makes a switch different from the hub is auto MDIX technology, which basically just means that it detects pin outputs on cables, and it can put them in the correct order. So that's why we don't need crossover cables or anything like that. We just use straight through cables. So what is a switch? So a switch is a device that adds port density to a network. So that is the simplest definition of a switch. There's also much more advanced things that you can do with it. You can also use it for just expanding a wired network. So instead of just having port density, just say, having a router and then putting 24 ports, you can actually cascade these and then I have ports for an entire network like we do here at our office. But also you can use it to add really advanced network management features, things like VLAN, where you can isolate users and/or work groups, and then we'll go into further detail with this. And then also QoS, where you can prioritize certain types of traffic, kind of like voice over IP. That would definitely be a priority for your network. And SNMP, Simple Network Management Protocol, which you use to manage your network. And also for PoE power sourcing, which is another thing we're going to be talking about today.
Yeah, and I wanted to mention something too. Hello, everyone. My name's Evan. But yeah, like Justin was saying, these do audio MDIX. There's no longer a designated uplink port, so we still get that question pretty often. With all of our current switch line, you can use any port for uplink or downlink to another switch for, like Justin said, like for cascading or daisy chaining purposes. So that also takes a lot of the frustration out of it too. So you could use actually any port, even a PoE port, to uplink to another switch, since there's a lot of safety precautions kind of built into.
Thank you, Evan. So let's talk about some of the different types of switches that we offer. So this is something that we get a lot. So for someone who isn't familiar, when they see all these different types of switches, it can be a little bit overwhelming if you don't understand what the differences are. So this is just a pretty simple breakdown. So these are kind of our WebSmart switches and our managed layer 2 switches. But here's what's really cool is we've actually taken a lot of managed layer 2 features and we've started to just put them in WebSmart switches. So pretty soon you're going to see that managed layer 2 tab go away, and then all the things that are listed right there are going to go right into that WebSmart tab. So we're really starting to condense that. So that's something you're going to see from us in the future, so our product lines are become a little simpler. So unmanaged switches, so a lot of them have full half duplex. So if you don't know what that means, so half duplex means it only communicates in one direction at the same time, whereas full duplex, it communicates in both directions simultaneously. So that's why when you see a switching capacity for any given switch, let's just use an example, 5 ports, and then it's a 1,000 base switch. So the switching capacity is going to be 10,000. It's going to be 10,000 megabits per second.
Yeah, and like with full duplex, basically, that's why sometimes you'll see on spec sheets it'll say like your Ethernet port's 200 megabits per second, or your gigabit ports is 2 gigabits per second. Reason being is because it's sending and receiving 1 gig each way, and that's basically what full duplex is. So you can actually get traffic back and forwards.
Yeah, what he said. That was a better way of explaining full half duplex. And also, a lot of these, all the gigabit models, they support jumbo frames, and then just really simple. What that is, it just crams more bytes into each individual frame, so you get more of that rated speed, because there's always going to be a certain percentage that you don't get. So having jumbo frame really helps you get all that speed. And auto MDIX already talked about, but also we have PoE models for unmanaged as well as WebSmart models.
Yeah, and then also jumbo frames, it's pretty cool. You're going to start seeing a lot more. I believe all of our gigabit switches come with some type of jumbo frame support. Basically what it is your normal MTU, your maximum transmission unit, I forget it, but the MTU packet size is usually 1,500 byte. And what jumbo packets do is it can actually expand that packet size up to, I believe 12,000 is like the max, but just think of it this way, you have these packets going across your network with 1,500 bytes, you can only fit 1,500 bytes of information, but with jumbo packets, you can fit a lot more information. So in turn, basically what happens in the end result is you get more throughput. So let's say you're looking at a gigabit connection, and what they call your payload data, the actual data minus the overhead, is going to be anywhere from 400 megabits per second, maybe to 500. But with the highest jumbo frame support, you can increase that up to 600 megabits per second, maybe even faster. So it does help, with the speed of your network as well. And like I said, most switches nowadays that are gigabit are going to have this feature.
Thank you, Evan. So the next product line that we have is our WebSmart switches. So what really separates WebSmart from unmanaged switches is now you have a web interface, meaning that the switch has an IP address which you can use to resolve some management features. So management features, you have things like SNMP 802.1x and STP, which is a spanning tree protocol, which is a redundancy protocol. And then also, the things I was talking about earlier, which we'll still get into in deeper explanation, things like VLAN, asymmetrical VLAN, quality of service, IGMP, trunking, and mirroring. Trunking and mirroring is that's probably one of the features that you probably use most if you're using switches. So let's just say, for example, you're using a 24-port gigabit switch, but you're using one link to get from switch to switch. So what you can actually do then is you can actually tell the switch to treat 2 links as if it were a single link. That way you can get a larger link between switches. That way you don't get any of that lag time. So that's probably the future that most of our customers would be interested in, because that's something that comes up pretty often. And also we have PoE models available for these. And so for Managed Layer 2, it just kind of expands on what WebSmart can already do, which is having different protocols of SNMP. So instead of having version 1, there's also version 2C and version 3 if you require those things in your network. And then also, instead of just having spanning tree protocol, it also offers a rapid spanning tree protocol or multiple spanning tree protocol. The only difference there is they're all redundancy protocols, but rapid spanning tree actually it lessens the downtime before it starts rerouting traffic, and multiple spanning tree is essentially spanning tree inside of a VLAN.
So what Justin was saying is they're really technical switches, and I think that's why we're kind of like phasing out the line. We only have 2 switches in this line anyways, and if you guys are familiar with networking, layer 2 basically is the data link layer, so any of these could qualify as a layer 2 switch. So WebSmart is basically kind of what we're going to stick with going forward, and you're going to see a lot of those features on the Managed Layer 2 switches go over to the WebSmart switches, and we start seeing these new firmware updates that are coming actually really soon. We actually do have a few of the switches that are already upgraded, so, and then all of our new PoE switches, the 1020 and the 1620, which we'll show you later. Those also have the more advanced features as well. So basically, Managed Layer 2 is for your core switch. You know, you wouldn't need many of them unless you had hundreds of users in your network. For the most part, you could basically use all WebSmart switches and supplement your solution with unmanaged, and that way you kind of save costs and you get the same basic functionality. There are some instances where people will need those advanced Managed Layer 2 switches, but for the most part, we see a lot of people just going to the WebSmart switches.
So actually a couple times in this presentation I've already mentioned the acronym VLAN. So let's actually talk a little bit more about that. So there's also probably a couple extra features that we'll spend more time talking about, just to kind of give you guys some brief examples of what these features are and how they can be used. So VLAN, the acronym, actually stands for Virtual Local Area Network, which is probably one of the few acronyms in networking that actually gives you an idea as to what it means and what it actually does. So let's just say, for example, so we have a switch here. And let's just say, what would be a good example for this? Let's just say maybe a coffee but they also want to have a security system, and they don't want, for example, people who use their Wi-Fi to be able to access their security system. That would be really bad. So what you can actually do is you can make certain ports invisible to other ports and all the devices connected to it. So this is just a kind of a simplistic way of diagramming this out and kind of showing you how this all works. It's a little bit more advanced when you go into the settings. It actually has to do with port tagging and whatnot. But in this example, so here we have VLAN 1, which is just connected to the internet. So that goes to the modem, or to the router and then to the modem. And then here we have VLAN 2, which is we just have some security cameras plugged in. In VLAN 3, we have some access points for internet. So VLAN 4 is going to be camera access only, and VLAN 5 is going to be camera plus the internet. So maybe VLAN 4 is where we put some of our storage drives and also our server for the security system. And VLAN 5, maybe that's our network admin, or network admins, also maybe the managers and the owners of the building. So here you can see in VLAN 3, anything that connects to here, they only get the internet access, which is correlated with this blue right here. So they wouldn't get any of that video feed.
Yeah, and then also, it's not just necessary for segregation, it is, but you can also do things like people will create a VLAN so they can prioritize the data on that VLAN. Let's say it's a camera network. You want to have, have the best bandwidth available from the switch. And so what VLANs also allow you to do is isolate these networks and then also prioritize the traffic this way. All your data users, or maybe like Justin's example, the people that come into the coffee shop, they don't bog down the network and we lose camera video or frame rate or resolution, or the cameras go down. So this way it isolates it, and then you can prioritize that traffic over others.
Thank you, Evan. That's a pretty good example. And another example that you might use in your business is, let's just say you have an e-commerce server where you have a lot of accounting files. You wouldn't want everyone in the company to be able to see those. So you can actually make those servers completely invisible instead of just having them password protected. So it adds another layer of protection. So another feature I want to talk just a little bit more about is SNMP, which is a simple network management protocol. And that's it pretty much is what it sounds like. It's just a protocol for managing your network. So our WebSmart switches and our Managed Layer 2 switches all support this feature. So what this actually does is it allows you to monitor traffic, and you can actually see what's going on inside your network to the minute detail. In smaller networks, this isn't that important. Like in your home network, you probably wouldn't really need something like this, but in a larger network, a lot of times you only have one IT person on staff. Sometimes maybe you have one IT person for multiple locations. So let's just say in this example you have New York, Manila, Toronto, all being managed by one IT person. So what you can actually do is you can actually go into software, or you can go into a command line interface and you actually see what's going on inside your network, so you can solve the problem much quicker. So let's just say in a larger company, if you can't solve the problem quickly, maybe your network is down for for half, or God forbid, an entire workday. So that's where SNMP can really come in handy, is in those larger networks.
Yeah, it's funny because one of our previous coworkers actually went and got a network admin job and works at home, which is crazy. But yeah, he uses SNMP and these types of remote tools to basically manage these networks across the globe, the nation or the globe. So SNMP, it doesn't look like a real fancy feature, but it's very useful in analyzing problems on your network, traffic problems, who's using the bandwidth, things like that. So it is convenient, and it is remotely accessible. So that's also a good benefit for it.
So, and just to get a little bit technical, so when it comes to SNMP and how it actually works, so you need to have switches that support SNMP to get the information, either in the command line interface or in say software, for example, SolarWinds, which is a good SNMP software that we've worked with. So let's just say you have half a dozen switches in your network, and then a couple of those switches are at the furthest end. So you'll only get SNMP information as far as you use SNMP switches. So let's just say you connect the unmanaged switch to an SNMP switch. Anything that connects to that unmanaged switch, that's not going to really be picked up by the software. So you want to make sure that if you want to have full, SNMP, that you use all SNMP switches. So connectivity. So the most common types of connectivity is just copper, copper switches. That's what we refer to as a standard switch. But we also have fiber optic cabling. So what this really comes in handy is just for long distances, because the maximum distance of copper or Ethernet is actually 100 meters or 328 feet, which is pretty good, for most networks. But sometimes you have remote locations or things that need a longer connection. So then you're going to have to go ahead and switch to fiber optic cabling, which you can actually go much further, actually up to 100 kilometers with single mode. And there's a few different requirements for some of these. For example, gigabit multimode is the only one that has this kind of weird requirement, where you can see right here 62.5 micron. So that will actually get you 220 meters on gigabit. But 50 micron will get you 550 meters. So that's just one thing you have to take into consideration.
Yeah, with fiber, basically when you're sticking to fast Ethernet at 100 megabits per second, everything that's on the spec sheet is basically holds true. So those go up to 2 kilometers. It doesn't matter if it's 50 micron cabling or if it's 62.5 micron cabling, it'll still go 2 kilometers. But as Justin said, the size of the core, and that's what it's relating to. So a 50 micron core is smaller, so the wave of light, doesn't have as far to travel, so it can go further. Bounce up and down the cladding inside. 62.5 micron is a bigger core diameter, and so that's why you get that limitation. But gigabit multi-mode is the only I guess feature, was it fiber standard that's like that. Like I said, when you go to like 100 megabits per second, you get up to 2 kilometers with multi-mode, no matter what the cabling.
And thank you, Evan. So that's so we're going to come back to this some more later. So we just want to kind of because this does have to do with switching. So we want to talk a little bit about the fiber, because a lot of times when you see the managed switches, they're always going to have a couple of SFP ports, which you can use, for fiber uplinks. So you can go from switch to switch using mini GBIC modules with fiber optic cabling. But we have a whole section for fiber optics, so we'll come back to that some more later. So for switch accessories, the biggest thing now, GBIC modules, we still have those, but no one really uses those anymore, just because it's kind of a little bit of an older technology, and they're really expensive. So so people that still have that equipment, they still use it. So we still have replacements for that. But really, what everyone uses now is mini GBIC modules, or also known as SFPs. They're actually they're the same thing, but the two terms are used interchangeably. So what these modules actually do is, you see, so these are two SFP ports on a WebSmart or managed layer 2 switch. So what we can actually do is you can pick up a couple of these mini GBIC modules and you can put them in these SFP ports, and that will actually give you the ability to use fiber optic cabling from switch to switch. So the next thing we're going to talk about is just PoE, or power over Ethernet. So this is becoming a very popular technology, which is why we have just a very big line of PoE switches and injectors now. So I definitely want to spend some time talking about that, since it's such an important technology, especially in the security industry, where a lot of people are switching over to IP systems now. So PoE just basically provides data and power over a single cable. And we conform to the 802.3 AF and 802.3 AT standards. So those are the IEEE standards for PoE. So anytime anyone asks us, can your PoE switch be used with so-and-so camera? Well, the answer is always that, we conform to these standards, and we'll work with anything else that conforms to these standards, which is the vast majority of PoE products on the network. There's very few proprietary PoE implementations. It's also usually either cameras that draw more than 30 watts. That anything like that's going to be proprietary, or say, for example, outdoor access points. Those are pretty often proprietary, and we have a few of those as well. So barring those two exceptions, it's pretty much always going to conform to the standards.
Just to give you an example, like how rare it is to really find the PoE++, as we kind of refer to it, that stuff that exceeds the 30-watt standard is a speed dome outdoor with IR, heater and cooler inside. So those are definitely not the norm. You will run into those, but generally what we see when people have those types of cameras, either they have to get the injector from that company or it's already bundled with the camera. So usually that problem's solved. But for your bullet cams, your indoor pan tilt cams, even your outdoor cams with infrared will all work under 30 watts. We have a 3-megapixel camera that works at, about 6 watts, 4 watts? So, it doesn't consume a lot of power, and that's pretty common for cameras. You don't see a lot of them really kind of exceeding 9 watts unless they're, like really like monster cameras with heater and coolers and stuff inside.
So I also want to touch a little bit more on the standards. So for when I talk about 802.3 AF, so that's 15.4 watts per port, and 802.3 AT is more commonly known as PoE+. That's 30 watts per port. And it just uses standard Cat5 Ethernet cable, and Cat5, Cat5e, Cat6, they'll all work. They all have 8 pins, and they'll all work just as well. So it is smart and safe. It uses low voltage and smart powering. So what we mean by this is it's not going to provide power to any device that doesn't require power. Because if you think about it, there's always going to be one device on a PoE switch that doesn't require power, whether it's a laptop or a server or NVR. There's always at least one device that doesn't require PoE, so we definitely don't want to break anything like that. So there's definitely a handshake communication between any device that's plugged into a PoE switch, where the switch will intelligently request the device if it needs power, and the device will basically not respond back, and then it won't provide power. So that's how this standard works. So then again, like we said earlier, so common applications are access points, IP cameras, and voice over IP systems. So this switch just goes through some of the power up stages for power over Ethernet. So this is a little more of a technical slide, but basically what you can the biggest thing that you can gather from this is that handshake I was talking about earlier, where it's not going to provide power that isn't requested. And so what we use is mode A. So there's 8 pins on an Ethernet cable. So for PoE, it actually only uses 4 of the pins. So mode A uses pins 1, 2, 3, and 6. So when you get into proprietary, that's when you actually see things that aren't standardized. That's where you're going to see it's using all 8 pins. And another thing that people ask us is, well, Gigabit uses all 8 pins. How can you have that and also do PoE? Well, the answer is actually uses the exact same pins for both power and data. So let's just do an example. This is kind of a wireless solution, but it's also a PoE solution. So let's just do a sample project just so we can kind of see how some of these devices work. So here's the situation, and this is one that I get probably maybe once a day, I would say, where someone just has an office building, in this case a 2-floor building, and then they want building-wide, high-speed Wi-Fi. But the thing that they want is they don't want to have to, as they walk around the building, have to connect to different SSIDs and everything like that. So we're going to show you how you can do that with some of our wireless products. And keep in mind that it isn't specific to the products that we're showing here, but these are maybe the products I would choose for this solution. So the solution that we're going to provide here is the roaming wireless network. This is how we refer to it, but I've heard it referred to a number of different ways. I've had one person in Colorado refer to it as a follow me, or I've had people call it just seamless Wi-Fi. So those are kind of terms that people are going to throw at you a lot.
Yeah, and then don't be confused with mesh, or not to be confused with mesh. So mesh is like a specific standard where it uses like wireless adapters plus access points, basically to get the best route to the internet or your network. With roaming, it's different because the access points are basically plugged in around the network and configured. And I think Justin actually has a slide on that, the different SSIDs and stuff. So it's not mesh, it is roaming, but you get similar coverage to mesh. It's just they don't have that protocol enabled.
Oh yeah, that's a very good point. Yeah, people ask us about mesh all the time, but really that's not something that you need to provide seamless Wi-Fi. But because the term is getting more popular, we have been getting more requests for it. So choosing an access point, again, this is one of those things where if you're not really familiar with network technology, or even if you are but you're not familiar with our product line, some of this can be very overwhelming. So let's just talk about some of the differences. So the 653 is just our basic ceiling mount PoE access point. It supports VLAN and also some different access point modes. The modes that you're going to see commonly in an access point. So the 735, which I believe will eventually replace the 653. So it does everything that the 653 can do, except it also supports SNMP. It's also plenum rated, for buildings that have that requirement. So what that actually means is certain buildings that they require plenum rated cabling and access points, and basically that just means if it catches fire, it's not going to emit toxic fumes.
Also, too, I mean, that's one main reason why you have to use it. But if the fire department comes in and they do an inspection, they can tell you to rip it out, and you have to rewire your cabling to the wall or whatever it is. So, and also choose the appropriate access point. So, if you always check with building codes when you're doing like business solutions, we always try to check that with the customer. Some people are able to just run normal cabling. Other people have to use the plenum rated. So just keep that in mind. And that one, the 735, the 1 second to the right, you can point to it, but that's the one that's plenum rated. The 753 to the right of that, even though it looks very, very similar, it actually does not have the plenum rated housing, but it is dual band. But just wanted to point that out to you guys.
Another cool thing about the 735 versus the 653, so even though the 735 retail is probably going to be 20 bucks or so more, it's also a little bit more powerful, so you definitely get something for that money. So in addition to getting kind of the extra features, you also get some extra output power. So pretty much the standard output power for an indoor access point is going to be 18 dBm. Well, the 735 actually has 23 dBm. So that's actually a pretty substantial increase. So that's one really cool thing about the 735.
Also, with the VLAN support, I don't know if you mentioned this yet, but when you're doing a VLAN network, you have to have all devices from edge to edge support VLAN. Otherwise, it'll break the VLAN and everyone can see each other again. So that's why these types of access points have VLAN support, so you can integrate them into your VLAN switches and VLAN router. But always keep that in mind. You can't just buy a VLAN access point and expect it to isolate to its specific VLAN, because you need the switch, you need the router as well. So computers aren't as important because you can do tagging on the port. So it's basically just your network appliances, your switches, your router, and of course your access points if you guys are using them.
That's a very good point. That's why as we continue on in the solution, we're actually going to use a managed switch that does support VLAN. So that's a very good point. And the 753, so the biggest thing about that is that it's dual band. It supports a lot of the same features, the SNMP and all the different access point features. But dual band is really cool. And then if you're not familiar, we'll talk about the benefits of dual band a little bit more later. But dual band in the wireless section of this presentation. But I really like dual band, for buildings, where they're like an apartment building where there's a lot of different access points going on and stuff like that. So it's really cool to have those two different frequencies to communicate on. So the last one is the 638 PAP. It's an oldie but goodie. That's why we've kept this product around, because it has detachable antennas, which actually isn't as much the norm these days. Most of the industry is kind of moving away from detachable antennas. But let's just say you wanted to use some higher gain antennas, or you have some laying around already. That's probably going to be the biggest thing with a 638 PAP. It kind of looks like a router, except for like 1/4 the size.
Oh yeah, I just wanted to add one thing to the 753. Let me go point to it real quick here. This one right here. I think Jess will mention it, like how to set it up, but this has a feature called band steering. And actually in the access points management interface, it's actually called band steer. What I like about it, it's a checkbox. That is it. You just have to enable it. And what it does is it actually will probe all the clients that are connected to it, whether it be a phone, laptop, desktop computer with a Wi-Fi card, and it'll see if that network adapter or that device has 5 gigahertz support. And what's cool about that is it'll automatically switch you over to the less congested frequency. So if there's a ton of people on 2.4, and you have half of those devices supporting both 2.4 and 5 gigahertz, it'll move enough people over to balance both bands out, so there's an equal amount of users. So that's a special feature that the 753 has. It is a new feature for TRENDnet, and so we've recommended to our PMs that we try to incorporate that into all the future dual band access points. But really cool feature.
So next, we're also going to need a PoE switch. So let's go through some of the unmanaged options. So one of the switches that we actually saw a lot of, it's a TPE-S44. So this has a 30-watt power budget. It's 4 ports PoE and 4 ports non-PoE. So it's extremely versatile, and it's fanless, and it's a pretty small switch. So this one, and it's actually priced very competitively, or very aggressively rather. So we actually sell a lot of these just because of how versatile it is, and the price, performance, and value of this product. And also we have the TPE-S80 here. I should have changed this slide because actually we recently replaced these with the TPE-T80H and the T160H. Is that right? Yeah. So it's basically the exact same switches, except where they also support PoE now. The same power budget, they support all the same standards. They're still rack mountable, except for now they also support PoE plus. And so you're getting more features for the same cost.
Sorry about that. I was muted. Yeah, can you go back one slide? So on the power budgets, I don't know if we've mentioned that yet. So if you see down here, like you'll see like the S44 has a 30-watt budget, the S80 has a 130-watt budget, and the 260, I'm sorry, the 160 has a 260-watt budget. If you guys aren't familiar with this, basically this means like the total power budget for the switch. So we know it can use up to 15 watts on this particular model since they're just PoE, standard PoE. But you always take that in consideration. So when you're doing a camera solution with PoE or VoIP PoE solution or access points, it's really good to plan ahead and get those spec sheets from the vendors if they're not us, and then go to their spec sheet and see power consumption. And just start adding up that and see if it it's below that power budget. If it is, then you're good, and you can use that switch for those particular devices. But if you exceed that budget, then you're going to have to either get a switch with a bigger budget or more ports. So that's something to keep in mind. The budget basically is total power that it can give out for PoE devices, and each port will be up to 15.4 watts. But like we mentioned before, there's not a lot of devices that pull that maximum draw. Like if you're looking at cameras, 3 to 6 watts on average. If you're looking at VoIP devices, again, under 12 watts. So generally, even though the power budget isn't 15.4 watts per port added up, it still would give you enough power to power your devices. So I mean, we've played around with the different power budgets and pricing structures, and we used to have full power budgets on everything, but we realized that customers don't use it, and so we'd like to save the customer a little bit of money, reduce the power budget, and that's basically kind of what we did. And we do have switches that are crazy powerful, like the 160H, but if you want to save some money, just do the math, look at your devices, add up the power consumption, and try to go for the lowest power budget, and that way you'll save a couple dollars too.
So we also have some managed PoE switches, so we'll just kind of go into some of the different options there. So the 1020 WS, this is one of my favorite switches. I'd probably say the 1620 is probably my favorite, but the 1020. So this has 8 PoE plus gigabit ports and also 2 non-PoE gigabit ports that are shared with the uplink ports. So those you can either just use copper or fiber for the uplink port. So it's very versatile. It's a relatively small switch, but it comes with the ear, so you can still rack on it if you want to. So this has a 75-watt total power budget, which will be good enough for most things. Because in this solution, actually use six access points that are kind of on the higher end of the power draw. Usually access points don't draw 12 watts, but I'm using some really cool dual band ones, so these actually use a little bit more power, and it was still able to support that. So some people kind of look at that 75-watt power budget, and they're kind of turned off by that, but really it's more than you think it would be, and it's priced very well. But the 1620, so if it's just you need additional devices or you need a little bit more power budget, this actually has a whopping 185-watt power budget. So this can handle pretty much anything you throw at it, unless you're doing all PoE cameras. And if you're doing that, we have a different switch for you as well.
And then also these two switches are probably our most popular. One, because they're all gigabit ports. They do have PoE and they have SFP, or the fiber slots that are available. So we sell a ton of them. We're coming out with a 24-port gigabit. We've gotten that request a lot. So we don't have it yet, but look out for that, and it'll definitely be priced competitively. Like I said, these two switches are amazing. These are the two switches I was talking about earlier that have the more advanced firmware and advanced features. One of my favorite things about these is the ability to actually throttle bandwidth by the kilobit per second level. Instead of having predefined throttling speeds per port, like 10, 100, and gigabit, I can actually say port 1 gets 512 kilobits per second. So I can really throttle certain ports. That way I can control my network bandwidth a little bit better.
And that brings us, last but not least, our TEG224WS. It also, I believe the model number now is the TPE224WS. We've had it styled as both. But basically, it's just a 24-port PoE switch. So the 24 PoE ports, those are 10100, which is really all you need for most PoE devices, because the camera is almost never going to be gigabit. Yeah, it's just because the camera can't possibly use that much data. So when you see 24 ports gigabit, it's because they're using gigabit access points. So that's really the only thing that you would need Yeah, or maybe like an NBR, but also you can use, in this case, the uplink port. So that's all that really matters, and when it comes to surveillance solutions, is having those gigabit uplink ports, so you don't get the lag between switch to switch. Since the cameras are all going to be 10100 anyway, so the only consideration you have is, again, that switch to switch speed. So as long as you're getting that gigabit there, and also you, like I said before, with trunking and link aggregation, is you can actually tell the switch to treat 2 ports as 1 link. So for this example solution, I'm just going to use 6 of the dual band access point, the 753 DAP, and also the 1020 WS. And again, I chose the managed switch just so I can implement some of those VLAN features.
Another cool thing too about this switch that people really like, and the 16 port I mentioned earlier, is you can actually disable PoE power per port, and that's really convenient for a lot of users because let's say you're remoting into the switch, you're not even at the physical location. Let's say you're that network admin working from home who's got a nice comfy job. You don't have to go to the office now to power cycle it, and it happens. Access point could freeze up, a camera could freeze up, and maybe or your firmware update, and you need to restart the access point. Instead of having to go there, unplug it, plug it back in to power cycle it, I can just log into the web interface and simply disable PoE, wait a couple seconds, re-enable PoE, and now I've essentially power cycled the device, and we're good to go again. And then I don't have to leave my cushy couch at home, so that's nice.
So if you were wondering why I was smiling during that explanation, it's because we actually have a slide for this that I jumped a little ahead of. So I'll let you say that again when we come back to that slide. So so here's a sample configuration of how I would set up all of these. So I definitely want to statically address everything outside the DHCP pool of my router. And the reason why I want to do this is, especially since I'm using 6 of these access points, it can be pretty hard to find the exact one I'm looking for, because then I have to go into the DHCP client list of the router, then I have to match up MAC addresses, and if I didn't have those written down, that's even worse, and I have to take down the unit and actually look at the label and see what the MAC address is. That would be terrible. So so it's best just to statically address everything.
And that's at least until we get our access point management software. So they just announced on our roadmap that for the ceiling mount access points that we're going to actually have a software that will be able to control them and discover them, set settings, all from one convenient application. Some other companies are doing it, and we kind of like that idea, and we've got a lot of requests for it, and so we're finally coming out with that. So that's kind of in the pipeline. So that should be also pretty convenient for IP addressing these as well, and also setting the SSID.
So now that takes us to the SSID settings. So you can have different SSIDs for 2.4 gigahertz and 5 gigahertz, but since I want to use band steering in the interface, which is what Evan talked about earlier, where you can actually steer clients to the 5 gigahertz network for devices that have that 5 gigahertz adapter. So I want to go ahead and I want to make those the same. So on both frequencies, I'm going to make it work Wi-Fi. And it doesn't really matter what the SSID is or network name. This is just all that matters is that they're all the same. And same goes for encryption type. Whatever encryption type you're comfortable with, go ahead and make that the same for all of these on both frequencies. And then, but you're going to want to, I accidentally clicked it there. You're going to want to use WPA2-PSK AES because that's just the highest level of encryption currently available. So anything less than that, I would consider to be not secure. And also, you want to make sure you don't use TKIP, because if you use TKIP, you're actually not getting that full encryption.
Also, too, they put this in the newer wireless standards that if you don't use WPA2 AES, you can still use the pre-share keyed method, but if you don't use WPA2 AES, you're actually not going to get the full speed of the rated wireless speed. So, like, if it's N600, you're not going to get that. You're going to get lower speed than that. So, it's also something to consider. If you want to maintain the full speed that that's quoted on the box or on the specs, you have to either have WPA2 AES. Again, you can use PSK or no encryption. You can't use WEP, you can't use WPA1, you can't use WPA TKIP. Always use AES. And there's really no added difficulty to using the AES. It's just a stronger encryption.
That's correct. Yeah, it's just a drop-down box in the menu settings, so it's not any more difficult to configure. Most of you probably use it and you don't even know it.
Yeah.
And so for encryption key, again, for both frequencies, for all units, I want to go ahead and make that the same. So this is very important. So the reason why I went ahead and made all these the same is that way the device basically, when you're walking around, it's not going to see all these different SSIDs. It's only going to see one. So it kind of tricks the device into thinking it's connected to the same thing when really it's going to be changing and resolving different access points. But here's what's really important too. So it's very important that I did all these things, but it's also very important that I changed the channels, and not just changing them, it's the way that I chose to change them. So for 2.4 gigahertz, I chose to use non-overlapping channels, and the only 3 non-overlapping channels for 2.4 are 1, 6, and 11. So since I'm using 6 access points, that's a multiple of 3. So it made sense just to use 1, 6, and 11 twice, and try to arrange them in such a way where 1 isn't next to 1, so on and so forth, when you're designing the layout. And the reason why you want to change channels is because some of these devices are actually pretty powerful, and they actually can interfere with each other if they're placed too close to each other, or if you didn't adjust the channel accordingly. So 5 gigahertz actually has many more unique channels. So you can actually go ahead for 5 gigahertz and give everything its own channel. Yeah, and again, when you get into the interface, make sure you enable band steering. So now we're just going to go through the implementation. And then it's pretty simple. I mean, you can actually, if a customer requests this, you can actually pretty much do this before you get on the job. Which IP addresses can I use? You can actually do everything beforehand. It should take like half an hour to just configure the switch, and also.
All right, yeah, I jumped the gun a little bit here, but this is what I was talking about when I was talking about the 1020 switch and the 1620. Actually, any PoE switch that has the WebSmart web interface that you see here. This is our new firmware in action. And what you see here is basically you see the ports listed out that are PoE, and you can see where the little red box is. It's kind of hard because it's so small, but basically there's enable and disable. And so, like I said before, to power cycle it, I switch it over to disable. I hit apply on that little right column, and then it turns off power. And then as soon as I hit enable again, we return power to the camera, and it's good. It's good to go again. But yeah, this is the web interface that people like so much.
Oh, also really cool is you can actually set priorities on this too, which I hadn't really messed with until recently. But you can actually set certain things to critical. So let's just say, I mean, I wouldn't advise this. Let's just say you're kind of pushing the power budget a little bit, and you're like, let's just see what happens. And if it doesn't work, then I'll replace the switch. So if you're just gonna give that a shot, then you can go ahead and set certain devices to critical, so certain devices will never go down.
Also, outside of the PoE functions of the switch, the new switches have that voice VLAN. We don't have a slide on it, but I just wanted to mention it because it's very convenient to set up voice over IP headsets with VLAN support very easily. Like, you don't have to go through your traditional VLAN setup. Instead, you use the identifier on the hardware, like the phone hardware, and it'll actually group all of your VoIP headsets into that VLAN and prioritize it, so that way you don't have to, because I mean VLANs is a little clunky setting it up, and is a little technical, especially tag-based. So voice VLAN takes a lot of the headaches out of it, and just makes it really simple to use. And one thing we don't mention a lot too is that we have really good support. So if you need help with any one of these features, your customer or you guys can call in at any time and get information about it and figure out how to set it up. And we have great user guides too, so we've been spending the last couple of years making really good detailed user guides and trying to show you guys how to set these things up so it's not so confusing and mysterious and things like that. So very easy to use, and but yeah, voice VLAN and being able to disable the PoE is probably the two most popular features on this one.
So again, some of the benefits of PoE is just cost saving. You can actually save money on the cost of just installing new power outlets. So that really only comes up, in security type solutions where you're dealing with a remote location that may not have power, but you're within that Ethernet cabling distance, so you can actually run power that way instead of having to install a new outlet. And then mobility again, so it just gives you more options instead of being kind of tied down to the location of the power outlet or having to use really long extension cords. Since you already have to run that network cable anyway, this gives you additional options. And then management, being able to, like Evan said, being able to control, the output configurations and everything like that. And while we're on the subject of PoE, I mean, it's not on the slide, but it's a question I get a lot, at a lot of the ADI expos where I go and I do this presentation is people ask me about outdoor wireless cameras. And the reason why you don't really see that, especially not with IP, maybe more with CCTV, but with IP, I mean, the reason why you don't see it is because it's very hard to get a good signal outside. Because usually in office buildings where you would use stuff like this, you're dealing with a lot of concrete, a lot of metal, things that really destroy wireless connections. So you're not really going to get a good connection anyway. So in that case, you're already going to have to run the cables, and then so since you're running the network cables anyway, to be able to power source from the same cables, I mean, it's just from the system integrator end, it's just very important, and I would always use PoE.
And also too with wireless cameras, you don't see them as often in the IP world, is because a lot of people believe they're not as secure, because I mean they're susceptible to wireless interference and things of that nature. Also, like Justin was saying, when you mount these, like let's say on a pole or outside on a roof, when you have a wireless camera, it's not PoE anymore. So now you have to have an additional outlet for that camera, or if you have multiple cameras at that location, now you have to have 3 or 4 outlets being installed. So by using a PoE switch, you install one outlet, you plug that PoE switch into that. Usually, like we just went to a site recently where they're doing a site survey for cameras, and basically what they did is they installed an outlet, they put a weatherproof box over it, put the PoE switch inside, and then ran the cable up to the cameras. And so, it does reduce the cost of having to buy those power outlets and call an electrician in to install, multiple power outlets instead of just the one using a PoE switch. And we even have solutions. Again, that same one we went to last week is they're using our PoE access points. So you can essentially have this kind of wireless PoE camera solution by incorporating our cameras plus our outdoor, our outdoor PoE access point.
So that brings us to our next networking medium. So I'm going to try to get through wireless as quickly as possible. I don't think we're going to be able to have much time to go into optical fiber and power line, but the wireless technology, and point-to-point type of solutions. So I definitely want to make sure we cover that. And be for the home type, what dual band means, and what frequency. Like in that solution, it's a little bit. So devices that use this frequency. So it's cordless telephones, neighboring wireless networks, which in apartment buildings is actually really huge. Bluetooth devices, microwave ovens, which is actually pretty huge because, for example, my coworker uses a 2.4 gigahertz headset, and anytime like his kids are microwaving something, I can't hear him talk. So microwave ovens, that's a real thing. Baby monitors and game controllers. I know Xbox controllers use they operate on the 2.4 gigahertz frequency as well. And Evan actually has a drone that he spent a lot of money on, and he flies in his breaks, but that actually uses 2.4 gigahertz as well. And then so 5 gigahertz, so 8 non-overlapping channels, 16 total channels, and then shared devices. Few or no other devices. I mean, really, the only things you're going to run into that use 5 gigahertz are high-end routers, which a lot of people don't have. So I mean, if you have a high-end router that supports 5 gigahertz, even in an apartment building, chances are there aren't that many of them out there. So you're really going to have a leg up when it comes to interference. So our AC1750 router, this has won a number of different awards, but you can actually see this on our website. So we won't go too much into this. We'll talk about our some outdoor bridging solution. Access one has no internet access. Buildings across the street from one another. So we actually used an outdoor wireless bridging solution. But also in the security industry, the thing you're more commonly going to run into is that it's a multiple building surveillance solution, and then one building, it either does have internet access or you want to, have everything managed under the same umbrella. So we're actually just going to go ahead and use some outdoor access points, and that's actually going to go ahead and solve that problem for us. So let's just do a 676 APBO. This is our outdoor access point. So this actually operates on 5 gigahertz, and this I use strictly for point-to-point bridging type solutions. So I'm going to use a bunch of our new IP cameras, and also some of our smaller PoE switches and some of our PoE access points. So this is going to be a full PoE solution. So here we have 3 buildings. So the 2 remote buildings, they also want, so building A is the only one that has internet access at the moment. So building B and building C, they also want, that area to be secure with the surveillance system, but they also want, high-speed Wi-Fi. So I'm actually going to use for the 676 APBO. I'm going to create 2 different wireless links, and there's 2 reasons why I did this. One, that way I'm not limited by the link by a single link at the main building. I have 2 separate links so I can get more data to the individual buildings. And also just because, this unit supports as I believe, a 30-degree horizontal beam width. So this is just a little bit beyond 30 degrees. So I went ahead and used 2 just to be safe. So the reason why I did that is twofold. So at the maximum, so this is actually rated for 7 kilometers, but we want to use the maximum speed. So really, safely, I can use about 1,500 meters and get the maximum speed. And then these are actually, the chipset is rated for 300 megabits per second, but really when it's all said and done, I'm going to get about 85 megabits per second. And that's not specific to this product or to us, that's just kind of wireless technology in general. So this is the number I would give, or I would use, when I'm doing a security type solution. That way they kind of give the integrator kind of a realistic expectation of what they're working with and how to spec everything out.
And that also plays a big role in, your camera selection. Or if you pick your cameras first, make sure you have enough bandwidth to carry that high definition video over that 85 megabit per second link. And so sometimes that limits how many cameras you can set up, or you have to lower your resolution or frame rate so you don't get any lag or jitter from the camera video. So always keep in mind, 3 megapixel camera can generate up to 18 megabits per second. If you have it full-blown resolution and 30 frames per second in the highest quality. So just always make sure that you kind of keep that in mind when you're setting up the actual wireless bridges and determining how many you need. So like Justin was saying, instead of using 1 at the main building, to make sure we had enough bandwidth for the cameras at building B and C, we ended up just putting 2 at our main building. So we basically have 2 pipelines going out to each location.
Okay, so that brings us to our last example solution of the day. So I'm going to use 3 of our 715 APOs. So these are IP55 rated. So for most regions in the U.S., you're going to be able to use this device. So the first number stands for dust protection. Second one is water protection. And then these actually have the ability to attach an omnidirectional antenna for point-to-multipoint solutions or for providing Wi-Fi. So I'm going to use one of our 8 decibel omnidirectional antennas. And again, some of our, our cameras, access points, and PoE switches. So again, a full PoE solution. So we're actually going to do a point-to-multiple-point solution. So real quick, the horizontal beam width on this device is 110 degrees. So let's just say we're beyond that 110 degrees. So I didn't measure this out, but I eyeballed it. This looks like 130 degrees maybe. So I went ahead and decided to use the omnidirectional antenna so we can get that full 360-degree coverage. And then, so that's actually going to bring down the distance a little bit of how far I can go. So these are actually, the maximum distance for these is 10 kilometers. But I want to use the maximum speed. I also want to use the omnidirectional antenna. Since it's using power is being spread out in multiple directions versus one specific direction, so that actually brings down the distance just a little bit. So that's why we're going to be working with 500 meters right here. And since I'm only using 1 unit at building A, I'm sharing that pipeline like Evan said. So link X and link Y combined are going to equal 65 megabits per second. So that's why I went a little bit more conservative with how many cameras and how many access points I use. But I easily could have just skipped the omnidirectional antenna and just put 2 of these units there. Because these, units retail for less than $150, and they're very cost efficient. So I very easily, if I wanted to have those 2 pipelines, I could have just thrown in another 715.
Also, something to note, with outdoor bridging, it's very important that you have line of sight, meaning that you can see, from where the access point is going to be mounted, you can see the other access point that it's going to talk to. If there's trees, foliage. If you mount them low enough where you encounter vehicles or traffic going across the street, it'll break your bridge. But the thing is, with these, if a car does drive past, it'll relink again. But for trees, for example, some people will build a bridge. Let's say in summertime or whatever, and there's no trees and leaves there's no leaves on the tree, and but then springtime comes around, and now you got all these leaves that have grown out, and now your bridge doesn't work, and now you have to go out and reposition everything. So always make sure you have line of sight with no obstructions in between the 2 access points that are going to be talking to each other.
And that's a very good point, yeah. So this happens quite a bit where, where someone doesn't have line of sight. So let's just say there wasn't a direct connection to building C. So what we can actually do is you can go from building A to building B to building C. And you can do that a couple of different ways. You could have an omnidirectional on the unit on building B, or you could just have 2 units and then have 2 unique bridges with different channels that are not interfering with each other. So there's a couple of different ways you can do that, but there are definitely ways around some of those situations. So here's our outdoor wireless access point offerings. We have the 14 decibel unit, the 455 APBO. This is Super G. This is another oldie but goodie. So this one is extremely robust unit. It can definitely take a beating. Not as fast as some of the newer units, but it can definitely take a beating. So it definitely has its place in our product lineup. And also the 715, which is what we just used in our example solution, and also our 676, which is we used in the first outdoor wireless solution. So that's the 5 gigahertz model. So if you were just going point to point, need something that's rated IP66, high speed, this one is definitely the way to go. So we definitely have some versatile outdoor wireless solutions, and we're coming out with a couple of different units as well, so we can kind of expand our outdoor point-to-point offerings. Since this is becoming such a popular solution, the reason why is because when it comes to remote locations with security cameras, I mean, honestly, the best way is to always run fiber. It's always the best way. But the problem is the best way is almost never the most cost-efficient way. So it costs a lot of money to to trench up all that ground and run all that fiber. So if you can get almost as good a performance from wireless, at a fraction of the cost, it's definitely a solution worth considering. And these devices have definitely come a long way in terms of what they can do and how well they perform.
Yeah, interesting, because I actually got a real number last time when we did the walk for Santa Monica City. So we were setting up some cameras and some bridges, and they mentioned how expensive it would be to trench to each location, and they said that it would be over $70,000 to run cable for the cameras and the access point. Or I'm sorry, for the cameras if they didn't use the access points. So they were like, "What? We can finish this solution under like $5,000," because they had a lot of access points and cameras and stuff, but a huge difference. So yeah, trenching any type of cabling is expensive. So when you have that type of situation, wireless is probably the best way to go and the cheapest for sure.
Okay, so that's about all the time that we have for the presentation of products. But I also just want to talk about a couple of different things. Let me just pull up this slide right here. So while I have you guys. As you can see, we have a lot of slides that we just kind of did the good stuff in our program, which is really cool for system integrators. So it's entirely free to sign up, and then basically the more products you sell, the bigger discounts you get. But the biggest thing, and you get this just for signing up, is just being able to skip our level 1 and 2 technical support. So that's really just for end users, home users, just because the problems that they have are usually quite easy, and they very seldom need to get escalated to the 3rd level technical support. But for people who are dealing with much larger installations, I mean, the level 1 and 2 technical support isn't really trained to deal with those issues. So you can save yourself a lot of time and actually just sign up for the partner program on our website. Just go ahead and go to TRENDnet.com, click on partners, and then go ahead and sign up for the partner program. Peter will give you a call back with some information, and that's going to allow you to circumvent that and go straight to our 3rd level technical support, which is here in the U.S. We actually sit right next to them. They all speak English, so you definitely don't have any worries about there. And the last thing I also really want to talk about is we're going to be at ESX in Nashville, Tennessee. So we're hoping to see some of you guys there. Our booth number is 226. So we're going to be there for the whole week. And then, so if you come up to our booth and you mention this webinar and give us your business card, we're going to enter you for a raffle for one of our PoE Plus switches. It's the TPE-TG44G, which is 4 ports PoE Plus, 4 ports regular. It's a really cool switch. Goes for a couple $100. So make sure you swing by, come see us at ESX. We'd love to talk to you about some of your solutions, show you firsthand some of our products, and also get you set up with that raffle.
Yeah, that TPE TG44, I actually use that at home. It's pretty good. I have a couple cameras. But yeah, so this is the time where you guys ask any questions about anything. As Jacqueline has mentioned in the chat, please type your questions there, and she'll relay them to us. We already have a few questions coming in. So Justin, I'm going to ask you a few here. So the first question we have was, do all of your managed switches, or all of our managed switches, have the SFP ports, and do SFP modules from other manufacturers work in your switches?
That's actually a really good question. So all of our managed switches, like I was talking about earlier, the WebSmart and the managed layer 2 switches, all of those are going to have SFP or mini GBIC ports. And then as far as other manufacturers go, so for the vast majority of manufacturers, you're going to be able to use their SFP modules with our switches and vice versa, but there are a few exceptions, people that use non-standard implementations. The first two that come to mind are definitely Cisco and Hewlett-Packard. They're pretty notorious for that, so I would be a little bit wary. I'm not 100% on that, but I would be concerned with maybe those two brands, but everything else should probably be okay.
Yeah, it's true. We run into that a lot. We finally kind of pinpointed what was wrong. I guess those, Cisco and I believe like HP ProCurve, some of their mini GBICs, or I'm sorry, their switches, they actually will scan the firmware of the SFP to make sure that it's Cisco. So it keeps you in that Cisco bubble, so you can never get out. But any other brand is fine. Even if you go with some of our competitors, mini GBICs and SFPs, it's fine as long as you buy our switch, at least one of our products. That works. But yeah, Cisco and HP are the only ones I'd be hesitant about. Everything else should be fine. All right, we have another question coming in here. So, are we currently working on or have plans to release gigabit power line adapters in the future? And maybe we should go back to the power line slides just to kind of give them a brief kind of rundown of what power line is before I guess we talk about the gigabit.
I would, but that's like 30 slides back. But yeah, so Powerline just basically uses your existing electrical wiring as a conduit to send data signals. So that's how I usually describe that. So where we're at right now is we just came out with the HomePlug AV2 chipsets, which are really advanced. So definitely check those out. We actually have the fastest ones on the market right now for HomePlug AV2. That's not our testing. That's independent testing done by a small net builder. So definitely check out our TPL-408E2K, but gigabit, that's something that we're definitely working on. They actually haven't even made the chipsets for this yet, so we don't even have the base to make those yet. But that's definitely something that they're working on, and we're probably going to be coming out within the near future. And then we're really excited about that because once that comes out, that's probably going to be the standard for a long time to come.
Yeah, and Powerline is probably my favorite technology. It used to be terrible in the past. They had two versions of Powerline that just didn't really work well. There was the, I think it was a 14 megabit per second and the 85 megabits per second, but that's long behind us now. Now we have 200 megabits per second Powerline, and we also have 500 megabits per second Powerline. And what's nice about Powerline, and this is why I like it so much, is like it's actually backwards compatible. So 200 can work with 500. So you can mix and match adapters. Just don't go slower than 200 megabits per second because that's old Powerline technology. But it's really convenient. We have a new kit that came out that is perfect for eliminating those dead spots, maybe in your den or in that back office. You can use the electrical circuitry in your house and put a Powerline access point in that remote office to now give you Wi-Fi coverage there. So Powerline is definitely cool. You can check it out on our website. We have a lot of different products and options as well. All right, next question was, let's see, can you connect outdoor omnidirectional antennas directly to the outdoor access points, or is there special cabling required?
Okay, so for the ones that I showed you, the three outdoor access points that I showed you, it's actually different situations for all three of them. So for the 676, it doesn't have the option for the omnidirectional antenna. For the 715, you can actually take our outdoor omnidirectional antennas. You can connect it directly to that because that's N-type male to N-type female. You don't need any cabling. You have the option to use cabling if you want. Let's just say if space is a concern, or if you want to have these things, arranged in such a way where the access point's under a little bit more cover, you can definitely use cabling, but definitely not necessary. In the case of the 455 APBO, that one actually has a special lightning arrestor kit, which we sell as well, which basically has the converter, so it makes it the appropriate gender connector, and also gives it a grounding wire, so your whole network doesn't go down if it's struck by lightning. The unit will still explode, but the rest of your network will be cool, which is what's really important.
All right. And the, you know that, is my mic on? Oh, there we go. Yeah, with the outdoor cabling, we've seen people actually use it with the 715, because we have a lot of customers in Canada, or, just in harsh weather environments that are, you need an IP66 or better access point. So by using the cables, you can keep that outdoor access point inside. Kind of defeats the purpose, but it allows you to actually use that high-powered radio and protect it from the weather by running the cable and the antenna outside and keeping, the IP55 access point indoors. So definitely useful. Last question. Let's see. What sets TRENDnet apart from other manufacturers, Justin? Please tell us.
Actually, I think we have a few more questions after that, but I'll still answer this one anyway. So what sets TRENDnet apart? So I guess there's a few different ways to answer this. But I think the biggest thing, sometimes, yeah, we do have products that are better, and then there's definitely instances of that. A lot of times we do have better pricing, but I wouldn't even say that's the biggest thing. We are a price performance leader, but I would say probably the biggest thing is just avenues of support. For example, I haven't talked about this yet, but what we do, we actually do pre-sale support. So you can actually call us with questions about your solution, and we can give you product recommendations. Yeah, in a sense, we are limited, by what we can do over the phone, without actually being there. But we can definitely, advise you in the best way that we can. And we also can set you up with some of our local reps. Maybe we can have a rep in your area. Manufacturers are come out and check out your solution as well. So that's definitely something that we can arrange. And also, our technical support. And our warranties. And we offer longer warranties than our competitors. And stuff like that, but also the partner program where you can kind of skip the level 1 and 2 technical support. I think a lot of people don't have that. So I'd probably say the biggest thing is support.
Yeah, sounds good. Yeah, definitely. That's you go to the manufacturers like Justin was saying, and their phone support is like what 90 days or 30 days sometimes, and you have to pay per incident. So it's in the details, I guess you'd say, like where we really kind of stand out. It's after you buy the product too, and before. You're going to get questions answered by me and Justin. We run the department for the entire TRENDnet, U.S. and international. So we get every type of question, solution, and everything. So we're pretty experienced in that. We can give you really a lot of good insight on what products to pick, where to place them. We have people that will send us aerial, like the Google satellite images of their property and go mark it up like I want access points here and here. What do you guys recommend? And that that's stuff that we can do for you guys. So that's why don't be afraid to use our email, contact us, call in. Just to keep in mind, we're on Pacific time, so we usually don't come in until around like 9 a.m., 8 a.m. to 9 a.m., and we're usually out by like no later than 6 p.m. So anytime after that, we do check our emails regularly. So we might even be able to answer it from home, but for the most part, if you do call in, just try to call in between those hours. Otherwise, you'll just get the voicemail. So, but I think, let's see if there's any more questions here. I think that is it. I think we're good.
I think Jacqueline is Skyping them to us.
No, that's it. I was talking to her right now.
Oh, okay.
Yeah.
Oh, and also,
go ahead. Sorry about that.
Oh, yeah. I just wanted to say one last thing is if you call us and we're not there, it's probably better to email us because sometimes we're out traveling. For example, next week we're going to be short-handed and we're both going to be traveling. But we'll both, have computers on us so we can, our responses may be delayed, but we'll still get back to you eventually. So if we're ever not there, it's probably best just to email us. That way we can still get back to you if we're not at the office. Go ahead, Jackie.
Okay. All right, well, thank you guys. Justin, Evan, that was lots of great detail, lots of informative content. We thank you. Callers on the line, I do suggest that you go ahead and take down their information. If you have any questions, if we didn't get to a question that you wanted to ask, please do follow up directly with Justin and Evan. I would like to remind everyone that this recording of the webinar will be available on the Members Only Resource Center at esaweb.org. If you look at your chat log, that information is there. CE accreditation requests can be emailed to me, and you'll see my email also in the chat log. And again, we hope that we're going to see you in Nashville. Please stop by the TRENDnet booth. The show floor is sure to be packed with lots of great manufacturers such as TRENDnet, and you can learn more about their products and services then. And we do have great educational tracks planned out, not just for installation and service, but also for business development and management, RMR, sales and marketing, and of course, central station operations. So once again, thank you to TRENDnet and to all the callers on the line for participating in today's webinar. We appreciate your time. We hope you found this content useful, and we hope you enjoy the rest of your day. Thanks again.
Thanks, guys.